This is video 14 for Unit 8. You want to turn to page 6 to classifying chemical reactions as redox reactions. So, redox reactions, also known as oxidation-reduction reactions, are redox is short for oxidation-reduction reactions. Oxidation is when you combine with oxygen and the atom or ion becomes more positive because of losing electrons. Reduction is loss of oxygen. The atom or ion becomes less negative because of the gaining of electrons. There are two tricks to help you remember this. Oil rig, oxidation is losing, reduction is gaining, and Leo, the lion, goes grr, or Leo goes grr. Lose electrons, oxidation, gain electrons, reductions. Leo, L-E-O, grr, G-E-R. Watch this animation. We can see that an oxidation-reduction reaction is occurring where one species is losing the electrons and the other species is gaining the electrons. So remember, oxidation is the loss of electrons, which is occurring on this side, and then reduction is a gaining of electrons. When we assign what's called an oxidation number, it's the charge of an atom or an ion. And these are the 8 rules. Free elements get an oxidation state of 0. So if an element is alone, like this hydrogen, then it's going to get an oxidation state of 0. Or this oxygen is all alone, so it's neutrally charged. The oxidation number on any simple ion is the charge of the ion. Meaning, if it's in group 1 on the periodic table, then it'll have a +1 charge. If it's in group 2, like the alkaline earth metals, it'll have a +2, and so forth. The sum of the oxidation states of all the atoms in the compound must equal the net charge of the compound. So here, the charges have to balance. +2 minus 2 add up to equal 0. And so that would be following rule number 3. The alkali metals in a compound are always +1 with no exception, whereas the other families might have some exceptions. Number 5, the halogens in compounds are always a -1. This applies to fluorine. However, chlorine, bromine, and iodine have the possibility of being other oxidation states. Number 6, alkaline earth metals, zinc and cadmium are always a +2 with no exception. Number 7, hydrogen in compounds is usually +1. Sometimes there's an exception, and oxygen is usually -2. Sometimes there's an exception for that as well. So oxidation and reduction always occur together. They both occur in redox reactions. In order for a reaction to be considered a redox reaction, there has to actually be a change in the oxidation number before and after the reaction. So see how hydrogen was 0 on the left side and now it's +1 on the right side? Because that is a change, that makes this a redox reaction. As opposed to this one where sodium's +1 before, it's still +1 after. The hydroxide's -1 before, still -1 after. Calcium +2, +2, and sulfate -2, -2. So because there are no changes, then this is actually not considered a redox reaction. So which of these below would be a redox reaction? And to make it short and simple, everything's a redox reaction except for a double replacement reaction. So because this is a double replacement reaction, 2 compounds form 2 compounds, then it is not a redox reaction. But anytime you have a single element, it's automatically a redox reaction. So this is synthesis. That's going to be redox, and this is single replacement. That's also going to be a redox reaction. Each of these reactions are redox reactions. Everything is a redox reaction except for a double replacement reaction. So let's look at these. Take a moment and identify which of these is a redox reaction and which one is not a redox reaction. Here we have one reactant, and it's breaking apart into 2 individual elements. Anytime you see an individual element, it is a redox reaction. So this is decomposition. This is combustion, single element, so that is a redox reaction. This one is double replacement because you have 2 compounds, first and last, get together to make this. Third and second get together to make this. so this one's not a redox reaction. We have single element plus single element forms one compound. That's a synthesis. Single elements are automatically redox. And finally, we have a single element plus a compound yields a single element plus a compound. This is single replacement, so that is also a redox reaction. So there are your answers. Now turn to page 16 in the back of your booklet and let's look at part 9 in the homework. Identify each of the following as redox or not redox. So remember, if it is a double replacement, then it's not a redox. So number 1, we have a compound plus a compound where it went first and last to make this, third and second to make this. So this is a double replacement reaction and therefore not a redox reaction. Number 2 is a compound plus a single element. When you see a single element, that automatically makes it a redox reaction. But to be very specific, this one is single replacement. This one, we have a compound plus a compound. That is going to be a double replacement reaction, and therefore this is not redox. And remember, in double replacement, it goes first and last, aluminum phosphate, third and second, sodium sulfate. Number 4, we have a single element plus a single element, and they combine. This is a synthesis reaction, and therefore it is a redox reaction. In number 5, we have a compound plus a compound yields 2 compounds. This is a double replacement reaction, which means that it is not redox. Again, you have first and last, zinc hydroxide, third, second, barium nitrate. And then in number 6, we have a compound yields 2 single elements. This is a decomposition reaction, and therefore it is a redox reaction. So everything's redox except for double replacement.